everyone. This is the cloud project that we have created, and this is the architecture diagram of the cloud project. We have designed our cloud project in such a way that it is flexible and it can be used for future use cases as well. Our cloud project runs inside the container instance. It's triggered through a queue, and we are also using cloud storage and the like blob containers and table for storing the results, and blob containers for having the training data and some input data set, as well as the result embeddings into specified containers, and to store the classified documents also we are using defined containers. So these are five different containers that we are using: three for as an input data set for training, and for understanding the purpose of the tool, like to document to classify container, and container to store generated embeddings, and likewise we are storing individual classification results and document similarity results, face similarity results, and experimental data as well. So we have created a visualization tool to see this. So in this, if you see that we have created a tool where we can see this distribution of resumes, crime articles and health articles and sport articles count. So we have done several runs, but this is one of run that I'm going to explain, like how we can understand the output. So we have trained around 500 data for claim article, health article and sport article. Like we have trained using 100 data each from different domain. But then in document to classify container, we decided to choose 500 data from each domain, and resumes we have added more profiles. So after the tool runs, we can see that based on the training data, it's approximately predicted correctly, close to crime articles as 502 and health articles as 497 and sport articles as 495. So it is more or less correctly predicted. It's not 100% accurate, but it's more or less predicted correctly, and we can see this count here, and we can also see how it's clustered together based on the embeddings with the help of PCA reduced chart, and we have referred a KNN based algorithm to reproduce this. It uses split algorithm that we have referred from GRGPT, and the general algorithm from the Python site. And then neighbors can be used to view the neighbors and the corresponding similarity scores, and embedding components for each file can be each different file can be selected here as well. So this helps us to view how similar the two files are between, and we can check the corresponding similarity score here. So this helps us to visualize the classification results, and to visualize the document similarity result, we have created a kind of scatter plot that tells us the different domains. We can check what is the most relevant scores and what is the least scores. For example, in this case for resumes, the resume health requirement and file name 2 has a good score of 0.6297. Likewise, we have other profiles as well, which is matching with the requirement. So what is this requirement document? So requirement document is something that container that we have created to look for the specific thing that user is trying to find it. So here, for example, if in the requirement container, if a tool owner is deciding to put the requirement of a job posting, and we are having all the profiles here in document to classify container, it will run, and we can find the most relevant profile from that among all the 1,000 profiles. So here, if you see, and we are just describing what is the experiment result for each run, and what is the approximate accuracy for the classification. This is done manually, and we are just telling where we have selected the data set. We are using Kaggle and other Wikipedia things to create data set, and the results are stored in the Azure table. And then yeah, this is where I want to highlight the importance of understanding the output, where this is the general job posting that we've downloaded from LinkedIn that has been converted into PDF and stored in the requirement container. And now when these results are stored with compared with the classified documents, we generate like 2000 comparison scores with this one requirement, and all these similarity scores are help us to understand that okay, it is much relevant. So if you see the job posting is mostly related to clinical and staff related for the nurse to coordinate patients related to that. So unit testing, trust policy, and assist patients. And if you see the profile is also much related to the healthcare domain, and she is also 20 years experience in nurse. So we can see that it is highly convincing to see that it is relevant. And we have also generated a chart where it displays all of those similarity scores as a whisker chart, and here you can see the top similarity scores here. So and this chart, as shown in UI, this chart helps us to view the top and most relevant score based on the threshold. So that's what we have tried to explain for one document, and we can use this to analyze uh, the better similarity. And yeah, this is the overall understanding how flexible this tool can be used for, and how can we find the most relevant profiles using this tool.